In this video, we're going to take a look at how covalent or molecular compounds form and how they're represented with Lewis structures. So in general, molecular compounds, they form by sharing electrons, not transferring like ionic ones. So when you have electrons that are being shared, they're usually shared in pairs, sort of two at a time. So you could have one pair, two pairs, or three pairs. And when you have electrons being shared, you call them bonding or bonded pairs. So you could have one shared pair, which is called a single bond, single covalent bond, represented by one line. So for example, right over here in this picture, you can see that hydrogen is sharing two electrons with oxygen. So that's one pair, which would be a single bond. You can have four electrons being shared. So if you look over here, this is four electrons being shared. That's two pairs. That's called a double bond, and it's represented by two lines. That's called a double bond. It's still a share, it's just you're sharing four in between those two elements. And then lastly, you could have three pairs of electrons being shared, or six electrons, and that's called a triple bond. So for example, if you look at the nitrogen over here, it's sharing six electrons between them, these six here. And so that would be represented by three lines, and that's called a triple covalent bond, where you're sharing six electrons. You'll notice that some electrons are not being shared. They belong to each individual atom, like these two here belong to this nitrogen, and these two here belong to this nitrogen. So we call those non-bonding pairs. So over here in this picture, you can see the bonding pair between H and O. Same thing here, but then here you have the non-bonding pair that just belongs to oxygen. Either way, at the end, what happens is that everything is happy. So oxygen has 1, 2, 3, 4, 5, 6, 7, 8 electrons in its last shell. Two of them are coming from hydrogen. Hydrogen shared its one, and this hydrogen shared its one, so that oxygen, that had 6 before, now has in its collection 8. Hydrogen is also happy. It had 1 to begin with and only needs 2 because it has one shell. So it's getting a share with oxygen, 1 there, and now it has 2. So they complete the collection by sharing rather than transferring like we saw in ionic. So this is represented with a Lewis diagram. And the Lewis diagram just shows everything as dots, so they're being shared here as dots, shared there as dots. You could also represent it with a structural formula, where you represent the dots, the shared pair, the bonding pairs, as lines. One pair is one line, right? Two pairs is two lines, three pairs is three lines. So it's called a structural formula. Instead, it shows you more about the structure. So if we look over here, we have water. This is a Lewis structure for water, and then it was converted to a structural formula here. So the dots were converted into single bonds here. Over here we had 4 electrons shared between carbon and oxygen, and same thing this side here. So we had to convert those dots into double bonds, 2 lines each, if we want to convert it to a structural formula. So here we have a Lewis structure for HCl. What I want you to do is pause the video and try to convert it to a structural formula. In other words, put the right number of lines between H and Cl depending on how many electrons are being shared. So pause the video, try it out. At this point, hopefully you've unpaused the video and you're trying it out. So you'll see that there are 2 electrons being shared between H and Cl. That's a single bond, so one line, one pair. You can redraw the Cl with its non-bonding pairs around it. The point is that Cl is happy now. It has 6 electrons, so 2, 4, 6, plus 2 in this line here, so that makes 8. Hydrogen is also happy because it has 2 in that line. It just needs 2. The reason it has 8 is because that chlorine has 8 is because it has 7 of its own, these ones, and then hydrogen comes in and shares this one to make it 8. And then hydrogen is also made happy, right? It's a mutually beneficial relationship here. Hydrogen has 1 electron, and then when sharing with the chlorine, it now has a total of 2 for itself, making it happy because it only has a first shell. It just needs 2. But you converted this into a single bond. In grade 11 chemistry, you would learn how to predict how to draw these Lewis structures. In grade 10, you'll be given Lewis structures like this, and you'll be asked to convert them to structural formulas. If you are interested in seeing how to draw Lewis structures to get some enrichment, there are some steps over here. You can try that out and check with your teacher to get some more feedback on that. So this would be for enrichment purposes.